All right, is that okay so far?
Yes.
Okay, this is the one that I couldn't remember. It was how to determine a horizontal asymptote. And this has like ways you have to look at it. And she did this. Asymptote. Okay. So there's three possibilities that could happen. The first possibility is that the denominator degree, and I'm just going to do it if you want like the whole sentence. She did that on her video, but I'm just going to try to make it short. If the denominator degree is bigger than the numerator degree, we don't need then. If that happens, we have a horizontal asymptote at y equals 0. So we kind of look at the degree of the denominator, we look at the degree of the numerator, we see which one's higher, and then if the denominator is greater than the numerator, then our horizontal asymptote is y equals 0. Okay? The next thing that could happen is that the denominator degree...
Do you have like earbuds or something?
Go look next to my bed.
Okay.
I have my headphones. I don't know if they'll work. If not, see if Declan does. If the denominator degree and the numerator degree are the same. So if they're both, you know, the first degree or the second degree, then we do y equals lead coefficient of numerator over lead coefficient of the denominator. And that would be your horizontal. So you're always going to pick one of these. Okay? And then the last one is obviously if the numerator degree is greater than the denominator degree.
Are they on your bed?
I think they're under my bed.
Okay.
If that's the case, there is no horizontal asymptote. I don't know if they'll work, but try them. And so that's the part that's a little bit confusing, is figuring out the horizontal asymptote. All right, and then the last, are you okay with that part so far?
Yeah.
Okay. The last thing you have to figure out if there's any holes. So this is if the original function, well, let me read it and make sure I do it right. If you simplify something out that would have created a 0 in the denominator, that becomes a hole. So I'm trying to think how to say this where it's not so mathematical. When simplifying, anything canceled from the denominator that would have caused it to be 0 is the whole. So I don't know if I don't think I said that very well, but when I do a couple problems, I think it'll help. I think you'll understand. I hope you'll understand it. If not, we'll get there. All right. So that's like the basic what she taught. I just put it a lot simpler and shorter. And so this is what I'm going to refer back to when I'm looking at it. Do you have any questions so far? It's okay if you don't quite understand it, but that's just what I'm going to refer back to as I do the problems. All right. Stop me if you start to feel like I'm going too fast or you need, and you can always do the chat. I'll try to keep looking up. I think it dings me. All right, so I'll just start working through the homework problems. So number 1 is f of x equals -4 over x minus 2. All right, we do eventually have to graph it, but before we graph it, we want to determine any holes or we want to determine any asymptotes. Okay, so the first thing you want to see is if there's any simplifying that you can be doing. Are there any chunks that can be crossed out? Because it's x minus 2 and then a -4, there's nothing we can do for simplifying. So as soon as you know you didn't simplify anything, there are no holes. Because in order for there to be a hole, it has to be something we simplified out, that we canceled out. Does that make sense?
Yeah.
Okay. So then I'm going to look at horizontal asymptote. And that's that list I just did, A, B, and C. So if we look at the degree of the numerator, there's no x's in the numerator, so... Really?
Yes.
Sorry, he's giving the cats treats. So there's no x in the numerator, so that's a degree of 0 on top. And then there's an x to the first on the bottom, so that's a degree of 1 on the bottom. So then that means our denominator is greater degree than our numerator. And so I just keep looking back at my notes. So I look at, see which one is that, make it. And in this case, it says if the denominator is higher than the numerator, then my horizontal asymptote is y equals 0. So that was just by looking at my notes. Does that make sense where I got that? Because I said a lot of words there. Okay. And then the vertical asymptote is whatever's you're left with. Oh, did I spell that wrong up there? No, it is one S. Have I been spelling it with 2 S's?
No.
Okay. Okay. I was worried I was spelling it wrong. Okay. So now is the vertical one is what we have to figure out what we're left with in the denominator. And what we're left with in the denominator is x minus 2. So what value of x would make the denominator 0? Yeah, so we don't want this to be 0. And so if we were to solve it, we don't want x to be 2. So our vertical asymptote is at x equals 2. Okay? So now I'm going to graph it. I start with putting in my asymptotes. And I'm going to use a highlighter so you can kind of see where they are. So y equals 0 is the x-axis. So here's my horizontal asymptote. That's the line we can get really close to but never cross there. And then my vertical asymptote is at, I should make this a little narrower. My vertical is x equals 2, and so that would be right here. Okay, so there's my 2 asymptotes. Can you see that okay?
Yeah.
All right, so then this is where I get out my calculator. I don't know if I can focus on both at once. We'll try. We'll see if it lets us. Because I kind of want to graph alongside it. All right, that's not too bad. It's not great, but all right. So what I do is I go to y equals, and I put in whatever I end up with after I simplify. So in this case, there was no simplifying. Always put the numerator and the denominator in parentheses, or the calculator gets confused. So it's parenthesis -4 close parenthesis divided by parenthesis x minus 2 close parenthesis. And then I'm going to hit graph. And you can see what's going on there. Are you guys still okay? Are you with me?
Yeah.
Okay. So the way she taught it to look at the table, let me text my son something real quick. Hold on. I'm not going to look at the table. I'm going to look at the actual graph, and I'm going to show you how I'm going to do that. Declan, Quinn, Declan, Amen, Quinn. Okay. All right. So if you there's a couple things I want to do. If there was a hole, I would look immediately to see where I was supposed to put the hole. But there's no hole in this case, so I don't have to worry about that. I'm just going to hit the trace key. And I don't know if you can see that on there, but I have my flashing light here, my flashing cursor. And I'm just going to move around and get some approximate values. So like at around 3, and so I'm not looking for perfect values here. I'm just going to go to around 3 is around -4.5. So 1, here's my 3, and then 1, 2, 3, 4.5. So I'm just going to put some approximates on there and then connect them. I'm not going to be overly picky. Just put a couple on, so then I'm going to come up around the curve a little bit. And 5 is -1.3. So 3, 4, 5 is -1.3. I might go back to the curve a little bit to get an idea. 3, -3. So it kind of looks like this. So all I'm doing is picking like 3 or 4 points that gives me an idea how to draw it. The big idea is to make sure that it's not crossing the asymptotes. Okay, now this is where I don't know how to jump over to the other one, except I quit trace. Okay, that's not what I meant to do. Second, just go to graph. Okay, and then I just kind of move my cursor over to the other one and I hit trace again. I think there's a trick to it, I just haven't found it. Oh, that's not what I said to do. All right, let's see if I move it.
It's stuck on the top one.
Huh?
Mine is on the top. Oh wait, if you just keep going,
It'll jump? Yeah, I think it does. I just don't know when it jumps. I can't figure out the pattern to the jump.
just keep clicking the right or left.
Oh, there it is. Okay. That's weird. So I do the same thing. I just look for 3 kind of values that'll give me the shape. So like 1.5, 8.25, 1, 2, 3, 4, 5, 6, 7, 8. So it's not going to be exactly the same as mine. I'm just trying to get a basic idea where this is. And then it looks like -1 and 1.3. So mine looks something like this. So I'm not looking for a perfect one. Oh, that looks terrible. But so I just hit the trace button and I just picked 3 values along the line, the curves. Is that helping? Does that make a little sense?
Yeah.
Okay. Number 3 is one of the hardest ones. So let's skip over to number 3. Because number 2 is pretty similar. So let's skip over to number 3. Are you good with this one?
Yeah.
Okay. So number 3 is f of x equals 2x plus 9 over 2x squared minus x minus 3. So again, this is where factoring comes in. I'm looking at that bottom and I need to factor it. It's always going to be able to factor somehow. That's the way we're going to do it. And so I already factored this. It's 2x minus 3 and x plus 1. So that's the factored form. So what we have then is 2x plus 9 over 2x minus 3 times x plus 1. And we need it in factored form so we can figure out our asymptotes. All right. So when I first did this, I was like, okay, this doesn't make any sense. Hi, Madigan. We're just doing homework 9-3. I'm just kind of doing some explanation on it. And so I forgot where I was. Oh, I was hoping that something would cancel out, but nothing cancels out. So now I start with my holes and asymptotes. Well, as soon as I know something didn't cancel out, since we didn't cancel anything out, there are no holes. The only time there are holes, hey Caleb, we're working on Algebra 2 right now if you want to listen. If we didn't cancel anything out, then there's no holes. All right, then we do our horizontal asymptote. And that's the one we go back to our checklist. And well, first I want to figure out what my degrees are. Well, the degree of my numerator is first, and the degree of my denominator is the second. Because remember, it's always the highest exponent. So that means my denominator is greater than my numerator in degree. So when I go back to that, that again is the first case, so that's y equals 0. And again, I'm just looking at my notes for that one. I don't have it memorized or anything because all the tests and stuff, as we're going to be home, are going to be open notes. So just have that handy. And that's why I wrote it down myself so I could remember, because there's no way I'd remember that. Okay. Now this case has actually 2 vertical asymptotes. Okay, the first vertical asymptote is where 2x minus 3 equals 0. And the other one, I'm going to turn this down a little bit, is where x plus 1 equals 0. So we have 2. Our first one, if we solve that first one, x is going to equal 3/2. And the other one's going to be x equals -1. Does that make sense where I got those numbers? Okay. So before I pull out my graphing calculator, I'm going to graph in any asymptotes that I have. So my first asymptote is at y equals 0, so that's my horizontal one. Okay. And then I have 2 vertical. So my first vertical is at 1.5 or 3/2. Oh, you can't see that color. Let me pick a different color. And again, you can see like I kind of wobbled there, but it's okay. I can tell what it is. And then -1.
Are you, what's the first one?
What?
The first pink one, is that at 2?
No, that's at 3/2, which is 1.5.
Oh, okay.
Let me try to fix it so it looks better. Maybe if I make it a little narrower. 1.5. I'll try not to. Okay, that's a little better. Oh, there we go. Okay. Are you okay with that now?
Yeah.
Okay, now this graph is weird. Really kind of weird. And again, this is, luckily now we have graphing calculators, because I remember doing this back in the day and you had to kind of figure it all out yourself. And that's what I was afraid of. I was like, I hope we're using the graphing calculator. So you can either put it in factored form or just in regular form. So again, I'm going to y equals, my numerators in parentheses, 2x plus 9 close parenthesis, divided by parenthesis 2x squared minus x minus 3 close parenthesis, and then hit graph. Oh, mine's not in a good place. I got to fix it. I'm going to change my window. Zoom standard. That's not right. That did not do what I wanted it to do. So my window's all screwed up. Huh?
There's 3.
Yes. That's what I said. This is a really weird graph. And so I'm really glad that we don't have to graph these by hand. that we can just kind of, and I'm going to do the same thing. I'm going to hit the trace key, and I'm going to get a couple points on each curve, put them on there, and make sure they don't cross the x-axis, the asymptotes. My biggest thing is figuring how to jump from one to the other right now. I'm still having trouble with that. So like when I turned on trace, mine automatically went to the vertex of that upside down parabola, which is kind of nice because that's what I want. So my first one is at 0, 3, and then this is really, really skinny, so I don't really need anything else on there. So that's my first part. I don't know how well you can see that. I'm hoping you can see it somewhat. And I'm just hitting trace and then I'm just trying to move from curve to curve. There we go. And I'm just picking 3 good points that are close enough to being something like 2 and 4.5 is kind of one. And then 3 and 1.2. And then it gets really close down here. So I only need really, then it kind of skims like that. So I'm just kind of getting points just for my own, so I kind of can get the shape. Let's see if I can get over to the other curve. Come on, go to the other curve. You're not going. Maybe go the other way. Okay, not that one. Okay, there we go. So 1.3 and 3. And then negative 2.75. And then the other, and then we're almost there. So I'm just using it as a guide. I'm just getting some points to guide me. And so that would be my final graph with the asymptotes. Does that make sense?
Yeah.
All right, let's do one. If we do number 4, that has everything in it. You want me to do number 4?
Yeah.
Okay. So number 4 is f of x equals x minus 2 all over x squared plus x minus 6. Now the numerator, there's nothing I can do with it, so I'm going to leave it alone. But the denominator can be factored into x plus 3 and x minus 2. And because these two chunks are the same, and remember, we always have to cancel out chunks when we have plus or minus, and they have to be exactly the same. X minus 2 and x minus 2 cancel out. So our simplified version is 1 over x plus 3. Does that make sense so far?
Yeah.
Okay. So now because something canceled out, there is a hole. And the hole is going to be a point. So I'm going to do a little different than she did it. I'm going to put the value that the x is going to be at this hole, and we're going to figure it out when we look at the graph. So we look at what we crossed out, and we crossed out x minus 2. That means there's going to be a hole at 2 and something else. We have to figure out what that point is, but we know the x value is 2, and that's because of this right here, x minus 2. In order for that to be 0, we'd have to put a 2 in there. So we're going to wait till we look at the graph, and I'll show you an easy way to find out where that hole is. Okay? It's not a line, it's just an open circle. The asymptotes are lines. Okay, so let's go back, and now we got to figure out our asymptotes. So our horizontal asymptote again, I'm going to look at the degrees. And it doesn't matter what you look at. The degrees are going to be the same in the simplified and the original. So in the original equation, in the numerator, we have a first degree. I mean, they're not going to be the same degree. They're going to have the same relationship. And in the denominator is a second degree. So again, the denominator degree is greater than the numerator degree. So when I look back at my notes, that's where y equals 0. So that's my horizontal asymptote. And then my vertical asymptote is what's left after I cancel out whatever's on the bottom there. That's going to be my vertical asymptote. So in this case, x plus 3 is left on the bottom. And we don't want that to equal 0. And so our asymptote is x equals negative 3. Is it starting to help where I'm getting, where these numbers are coming from?
Yeah.
Okay. And then we're going to graph. Let me move this over because we're over in the negative world more. Excuse me, I want you to erase. All right, there's a couple things you can do to find the hole. I usually put the hole in right away. That's my first step. So I go to my calculator. I plug in my, you can plug in the simplified or the original. I'm going to go with the original, the simplified because it's easier. So 1 divided by parenthesis x plus 3, close parenthesis, and I'm going to hit graph. And you're not going to see any holes. We have to know that there is a hole and we have to figure out where it is. The easiest way to do that, I think, is to go to second calc. I don't know if you can see me pointing, second, and then trace, and choose a value. So I'm choosing number 1, and I want to know when x is 2, what is y, because that's where my hole is going to be. And so I put a 2 in, and I hit enter, and I get 0.2, so that I'm going to fill that part into my hole. So all I did was kind of get the value there. So now I know at 2.2, there's a hole. So it's kind of close. If you can see, I kind of just tried to draw it as close to the x-axis as possible. And so I draw that in first so I don't forget about it.
Could you show us the graph by chance?
The graphing calculator? Or?
On your iPad.
Oh, yeah. Can you see over there? Oh, here.
No.
Is that too far? Which way? Am I moving it the wrong way now? This way?
Left.
My left, this way?
No, the opposite way.
Okay. My left is opposite. It's all weird to me, so I can't tell. Can you see it now?
Yeah.
So all I did was put a hole right here. And now I'm going to draw in my asymptotes. So my first asymptote is y equals 0. And then my other asymptote is x equals negative 3. And then I'm going to do the same thing that I was doing before, where I'm tracing on my calculator and just finding some values. I just know when I go to draw that one that there's a hole there, so I know not to draw there. So let's see. If I'm tracing, let's see. Negative 3 is way up at 33, so I'm going to come down to negative 2.5 and 1.7. Negative 2.5 and 1.7. And then it comes quickly down to negative 1. And then, so I just kind of get the shape. Once I see the shape, I draw it in. And just make sure I don't cross over that hole.
And you cross through the hole?
Huh?
You cross through the hole?
No, I skip over it.
Oh.
I mean, if you cross through it, I'm probably not, I'm going to see that you made a hole there and you just need me to, you just accidentally crossed over it.
So you kind of just go over it?
Yeah, you kind of skip over it. That's why I draw it in first, so I don't have to worry about it later. 3.5 and then 1.5. And then the other side has no hole, so I can just draw it completely like that. Does that help? What if I do one more? I was going to do 5 or 6 because they both come out as lines. Do you need me to do 5 or 6, or do you feel like you're good?
Do 6.
Okay. All right. Are we good with number 4 then? Can I scroll?
Yeah.
Okay. Number 6 says f of x equals x squared minus 7x plus 12 over x minus 3. So this time the numerator can be factored. And so we get x minus 3 parenthesis times x minus 4, and that's all over x minus 3. And so I see a chunk that can be canceled out. As soon as I know I'm canceling something, I know I'm going to have a hole. So I'm canceling these out. And what I'm left with is f of x equals x minus 4, which is just a line that starts at -4 with a slope of 1. So I may not, you can use your graphing calculator for that, or you can just graph it. All right, so then I'm going to look at my holes. So I know I have a hole. The question is where? Well, I crossed out the x minus 3. So the x value of the hole is going to be 3, and I don't know what the y value is yet. I can plug it in if I want and just do 3 minus 4 and figure that out, or you can use your graphing calculator and figure it out. So if we put in x, if you replace x with 3, you would get -1 as your y value of the hole. So it would be 3, -1 as your hole. And then your horizontal asymptote. Is going to be, we want to look at so the degree of the numerator is second degree, and the degree of the denominator is first degree. So the numerator is greater than the denominator, therefore there's no horizontal asymptote. And I only know that because I'm looking at my notes. You can just put none there, or NA I think she put. Okay, and then my vertical asymptote is what's left after we simplify the function. Well, in this case, there's a 1 left in the denominator. There's no x left in the denominator. Therefore, we don't have a vertical asymptote because there's no denominator to go to 0. So the only thing in this problem we need to worry about is that hole. So when I go to graph it, like I said, I like to put, you don't have to, it doesn't matter. This is just the way I do it. I like to put the hole in first and then finish off the graph. So I know I have a hole at 3, -1. 1, 2, 3, -1. So I have a hole there. And then I just graph my line. I mean, you could do it on a graphing calculator, but my line starts at -4. My slope is up 1 over 1. And then I draw a line that skips over that hole. Does that make sense?
Yeah.
Did that help doing those 3? I don't know how many we did, but we did a couple.
Yeah, but I have a question on number 2.
Yeah.
They're both to the degree of 1. So
Yep.
what do I do for the horizontal one?
Okay, so for the horizontal asymptote, for number 2, you're right. They're both a degree of 1. And so if I go back to that second scenario there, if the degree of the numerator and the denominator are the same, you take the lead coefficient. Let me write the problem. So the lead coefficient of the numerator is 1, and the lead coefficient of the denominator is 1. And so to figure out your horizontal asymptote here, you take those two numbers, the numerator, denominator, lead coefficient, and that's going to be your horizontal. So it's going to be y equals 1. Does that make sense? So that's the part, that second scenario when they're the same is kind of a pain in the butt, because then you take the lead coefficients of numerator, denominator, and divide them.
And then what would be the vertical asymptote?
In this case, because we don't so there's no holes because there's nothing to cancel out. So as soon as you don't cancel out, you say no hole. The vertical asymptote there is I look at my denominator and it's x minus 2. So then my vertical asymptote is x equals 2. Because that's what's left. Oh, sorry. That's what's left in the denominator. Does that help?
Yeah.
Do you have any other questions on the home? I mean, I feel like I did most of it, but do you feel like you kind of have an idea how this works?
Yeah.
Okay. Any other questions from the homework that you want me to do?